this video I will show you how DCVG works. I invented it in about 1974-75 when I was in Nigeria, and I was presented with a problem that particularly Bomu manifold had been bombed and destroyed, and what the company Shell had done is built another manifold over the top, connecting some pipes to the old manifold and not connecting others. And the problem was, since then, a variety of corrosion engineers had tried to get cathodic protection and installed, I think it was about 3 transformer rectifiers to try and get the readings that they were supposed to get according to NACE. But of course this is impossible anyway. But nonetheless, I had to find out what was underground without digging the whole place up first. So I reasoned that because this is a pipeline, by the way. This is a pipeline. This is what we might call the drain point or a test point. And it's coated, and it has 2 coating faults here and here. And this wet cloth is the backfill. And we can make our measurements when we have put some cathodic protection current through the system using a battery, and this will be connected to the pipe. So this is the drain point and connected to the negative of the battery, and this is the ground bed input, which is connected to the, oops, let me put it on there, that's connected to the positive of the battery. Now this is a 12-volt battery, and previous demonstrations I put a resistor, variable resistance, into the negative side of the system so that I could produce a variety of voltages. But to make this simple, I have just put a 12-volt charge between here and here, and that charge is going into the whole of the ground, and it's connected to the stainless steel tray. It's a cooking tray that I use, and those charges go into what is now remote Earth. The charges have spread all over this container. So if this was in the field, this whole area is made positive in relation to the pipeline, which is being made negative because the charges are being drained off to complete the circuit back into the battery. That's the way electricity works. Now what we have here is this is a copper sulfate electrode. This is connected to the positive side of the meter, as you can see, and this is another copper sulfate electrode which is connected to the negative side of the meter. Now the meter is on volts, DC volts, and I'm switching it on, and you will see that there is a difference in the ground here and here. Well, we can see that that is, just a moment, 288.5 millivolts. So I will leave this in the same position and find out what the ground is here in relation to this one. So it's 1.362 volts, and here 1.366, and here is 0.639. And now I will go over the coating fault, and this is 10.73 volts, and as I go along the pipeline, there's no coating fault here, and it's 1 volt, 393 millivolts, 916 millivolts, and over the second coating fault it is 7 volts, 5 volts, 8 volts. So we have a situation where by stepping one of these copper sulfate electrodes over the ground, over the top of the pipeline, we can find the voltage that is coming from remote earth, that's the whole of the ground, and going into the pipe. This is how DCVG works, okay? But what you're familiar with when you're doing DCVG is you have two here, and you step them. You put them like this, and the voltage is recorded, and then you put them like that, and the voltage is recorded. You put them like that, the voltage is recorded, voltage is recorded, voltage is recorded. Now that is the way that I used at Bomu Manifold for the very first DCVG survey in the world. Switch that off. Put these back in their containers. That back in its containers. So, this setup here, you can actually set it up yourself. Anybody can do this. And I want you to set it up yourselves with your own instruments, and you can even use your DCVG meters, and you can check out everything I've said yourself for an experiment for yourself to confirm that what I'm saying is indeed true, and it is how science works. Okay?